we used yesterday. I guess this is it. Yeah. So what I just to do yesterday is just to get this code. Okay. Let's see if we can do the correction. So we are using let's we are using tuple first. Are we together? So let's say we are asked to create two simple 4 by 4 tables for a production company with the following columns: goods type. So here you should have goods type. Here you should have quantity. While in this other place you should have the costs, and here you should have profits. Okay. Please, if you can see my screen, just let me know. So here we should have profits. Yeah. All right. Thank you. So you can see now that this is a tuple, but we are using the idea of tuples of what? Tuples of lists. So we put everything into a list and we have it as a tuple. So each of those items we have been are given as tuple. Okay. This guy should put us volume to mute himself. Okay. This type. So what do we call it? So if you don't have any ghost type, just say ghost type what? Ghost type, just say product what? I call it products A. The cost of product A is what? Let's say it's 120,000. Then in thousand. Okay. Let's say the quantity produced is 120 and the unit cost is maybe is let's say 100 naira and the profit is making is 180 naira. So 1, 2, 3, 4, yeah. So you also put this as what? As a tuple. Then you can copy this and paste it here and So one thing about programming is just for the lazy guys. So we often rely on copy and paste. So copy paste. So this is product what? Product B. This is product C, and this is product D. All right. So we can change this from 120 to maybe there's increase in production the following day to 200, and the profit, the unit cost is maybe 400 naira, and the profit is 280 naira. That's a good business. Maybe the unit cost of this is 300, the unit price go for 500, and the profit is what? Is let's say 150 naira. The more they produce, like, so this other product is goes for like maybe 50, and the unit price is, let's say, 1,000 naira, and the profit there is 10 naira. All right, so let's run our table. Can you see the table now? So this is what is expected from you yesterday. So you can also create it as a dictionary. So this is the table for the tuples. So you can also create it as a dictionary. Okay. So as a dictionary, please, if you have any question, please just feel free to ask. Okay, feel free to ask. For a dictionary, copy this. It's a list of a table. Then, but this will be what? Be a dictionary. Hope this is clear. Please provide response. It's clear.
Sorry, sir, I have a
Please
question.
ask.
Okay, it's on this thing that you did. You just edited it. So beneath the words you are typing, that this for row in table print F, and then you put the other one row
Okay.
0 to row 10. I don't understand that.
Okay. Yeah. I'm trying to put a restriction. I can I can also remove this. I think it should work. If even though I don't put this restriction. Let's say for row, I think let me see. I think it should also work. It also work. Okay. So what I just did is just to put a restriction.
Uh,
So, but for F formatting, if you want to format with F format, okay, let me give you a very simple case using F format. Um, Using F format, let me say I want to, F format is a way of formatting tables or formatting strings uh, with a keyword in Python called F format. So let me think of a good example. Say, let's say X or let me define a variable x, or let me say name. Hmm. Mhm. Okay, let me just say name is what? Name. So when you have two variables, you want to format them. Say name. My variable name is called name. Is assigned to a string called Alice. Okay. And my second variable is age. Is assigned to a string or to a number, maybe 30. All right. So, and I want to print age and print age. I just want to write some statement that okay, my my friends my friend's age, or my friend, or my age. Let me just use that. Okay, my friend age is what? Is age, and mm, my friend name is name, because I have a variable called name, and the age. I'll continue, and he is something years old. He is age. He is age years old. All right. It also should be on screen. All right. So you can see now. I have defined this. Let me print this. Let's see. Oh, it said he is okay. Age is a variable. Sorry. Hmm. Okay. Hold on. Let me just do this. Print name. You print name and also print age. All right. So Alice is 13. All right. But I want to add a comment. I want to add a comment. I will say put it in a string. Yeah. My friend is my friend name. My friend name. My friend name. Okay, let me have name here. Is right. So we have something like this. So it's going to return this comment. My friend name is Alice, and so she is all right. You can see now. This is it. My friend name is Alice. She's 30 years. So she's 30 years old. All right. So you can see the problem I'm having trying to put each of these words into strings without with care being given to the variable. This is my variable name. Name should not be in string. You can see that. Age should not be in string. So with this, we're going to lead to a lot of errors. Okay, I want a new line. So with this, it's going to lead me to different errors. So now I want to use a method called the F method. So which will just give me freedom to type anything I want, but putting my variables into what? So this is another method. So here's another method of doing it. This is an old method. You can just say, oh, this is a second method of using the formatting keyword. Say, my friend name is put that variable. We're having two variables, right? So put them in a curly bracket. This is variable one, this is variable two. Then using the formatting keyword. So you just type your word. My friend name is Alice. That Alice, put it in the square bracket. Then she is what? She is the age, which we know is a variable. Hold it in a bracket. Then using the formatting keyword. This is a Python keyword format. So she takes your variable. So if you're having a third variable, you can also put it here. Say, okay, this is another variable. So let me say I have another variable. So maybe the city. City is what? Is maybe Kaduna. All right. So my friend name is Alice. She is um, uh, X or something years old and lives in, so you put it in a bracket, in that city. So here you recall your variable city. So this is another method of formatting. So let's see. So yeah, you can see it now. It filled it by itself. The name of my name is Alice. She's 8 years old. She's 30 years old and lives in Kaduna. This is a second method. A third method of doing that is using the F keyword. You can see. So the F keyword is something like what we did here now. So this is the F keyword, which is a very good method, or is the let's say the most recent method of doing that. So F, just put F, which is like format, then put a string, then type whatever you want to type, but to just recall your variables. In this case, in this second method, you can easily forget all your variables. Maybe I'm defining 10 variables, for instance. So you just put 10 brackets and you will be having difficulties to remember which is which. You understand now? So, but for this case now, this F method gives you the opportunity to specify, okay, in this place, I'm putting my name, I'm putting the age, I'm putting the city where she lives. So into it and voila. So this is the three methods of defining or formatting your string with conveniences. So the third method is what we used yesterday. So this is the third method. I only added restrictions to it so that because my table, I don't want it to be more than four, five, um, 4 rows, that of yesterday. So I don't want the table to be more than, I don't want the rows to be more than 10. So I don't want the columns to be more than what? To be more than 5. You understand? Like in our case today, we're having 4. You understand? So, and I want each column to have a certain space. You can say the space I define between them. This is the third one doing it. Okay, this each column should have a space of what? Of 10 units between them. You understand? So that's why the table looks so beautiful. So when I remove those restrictions now, look at what we get. Where's our previous one? Yeah. You can see now that there is no space in between them anymore. So everything looks so close together. It's almost tending to the first type of table which you have. You understand?
When you were like
Okay, here,
not
right?
necessarily uh okay, your screen is not showing yet. Okay. Okay. It's showing now.
All right. So you got it to this third
Okay,
example.
yes, you did the third one already.
Yeah. So
Yes, you did it. You
yeah, and I was
just finished one plate.
yeah, and I was saying that this restriction we have here was just to what? Was just to give us some clarity. Like I just mean that we only have less than 10 rows. We should have less than 10 rows in this column. We should have less than what's it called? We should have less than 10 rows, less than 10 column, and the space between them should be like 10 units in between them. So that was what I was saying. Okay, I'm missing the brackets. So print f, something is missing. All right. So where is this thing? Okay, we are not done with this table yet. So now this is about the table. So I was saying that for this table, we I added those restrictions like things like this. This row should be less than 5, this one should be less than 10, this one should be, yeah, to make, look at the space between each of them to be like 10 units in between them. So those were the restrictions that we added yesterday. So and the row should not be more than 5, the color should not be more than 10, so things like that. So it's just for the to make the table look so fancy. Okay, so and I said these are the three methods of doing that. So with that in mind, so we can also define our assignment using a dictionary. So this is a dictionary. So I I'm creating, because I have so many lists, I have 4 lists to follow. So it becomes list of what? List of dictionary. So because there are many. So if it's just one, you define one dictionary. So but in this case now we are having a list of what? A list of dictionary. So now remember that our dictionary take what? Take in fact this one too are not necessary. Let me take this one out. This is the most important one. So it takes a pair. So this is a pair. So ghost type, and what's the ghost type? We call it pro.a, right? So here the ghost type is what? Is pro.a. Pro.a. and the quantity type, the quantity takes what? Takes maybe 10 or takes 100. The unit cost takes an integer, say 20 naira, and the profit takes what? Takes, let's say, 30 naira. So this is for product A. You can copy this now and paste it for what? Product B. So this is product B. So maybe the quantity has changed from 100 to 200. Maybe the unit cost has increased from 20 to 120, and the profit has increased by 100 times. So, or 10 times, yeah. So now we can also paste for the third column. So this is product C. I hope this is clear. So maybe it's 250, and the unit cost is, let's say, 230, and the profit is expected to make is 150 naira. And the last product is product D, and the quantity is like, maybe the quantity is so small, take it to 50, and the unit cost is maybe 20 or 40, and the product is maybe 130. So you run this. Oh, what is it saying? Okay, it's like it's saying that, oh, our formatting type, he doesn't understand it. So let's find. So one thing with Python, you continue to run to errors, but don't be scared. Okay, errors is part of programming. So errors is part of programming. So what do we do? Let's quickly sort this out. So for tables, okay, we cannot say for rows now in tables because we are using a dictionary which takes two items. So we need to be careful about that. We need to be careful about that. Okay. So we need to be careful about that. So um, for us to be able to handle this, what should we do? So we are having so many. We can look through each item in the each of those columns. Okay, you can look through each of those items in the columns and print them out. Let's see, but I don't know how the output will be. That's just my only fear. So, but let's see if we are going to look through. So let's start. So we can just say for each of those items, the goods type, the quantity, the cost, and the profit. Then we print. So let's say that for goods type, for goods type, for quantity, cost in table, print your f what? Print your f string for this. Okay. And let's see how this looks like first. So good. You only print cost and you only print cost and you only print the cost, so it's not adding the quantity to it. So there's a problem. What should we do? What should we do to handle this? Hmm, any suggestion? So we can fix each of those items inside, although we can fix them there, but I just want us to go through a right way of handling it. Okay, this is no type of table we are expecting. So this method will not work. Let us use um, okay. Let's add some affiliations to this. Ghost type, put it as a string so that it takes its mm-mm, mm-mm. For ghost type in this, no, this is not what we should use. Just do for rows and table, print rows of good type. Let me see that first. This will work. No. Okay. This our code is not working. So, but I'll figure it out before we finish our class. Let's just keep that first. Okay. Let's do other things.
Okay, sir.
Hmm. I'll figure that out for the end of the table, for the end of the class. Let's just hold it. But this is what I expect you to how to define it. Then we can print it at the table. So we'll continue with that. So for today's class, we want to quickly look at two things first. We are doing two part of the lesson. The first part is the theoretical part, and the second part we'll do a little coding. All right. So for today, we are reviewing the third book. I said yesterday we have the first book. So this is the first book. I will send them to us. This is the first book we are using. This is the second book, and this is the third book. Python data. So now let's quickly review some background knowledge about this. So we are looking forward, we are using the third book, just a little bit, the third book. So let's get some what has happened in data science as at large, the steps, the process, and so before we go into it in details. So like we said yesterday, that mathematics and what's it called? And data science. So introduction to data science. So I hope my screen is visible. Yeah,
Yes, sir.
thank you. So we said data science or data analysis is just a process of extracting information from where? From data. Just the way this guy defined it to us yesterday. So this guy told us clearly that we need to extract values. So data science involve collection of techniques used to extract values from data. So also, yeah, what we are saying here. So the analysis, we are trying to get what? Information. So that's just the end goal. So why we are doing data science or doing data analysis is to get what? Is to get information, to be able to communicate, to be able to make decision. Okay. So that is the idea of data analysis. So data analysis is just what? It's just a sequence of process of extracting what? Information from raw data. Okay. So this is it. So let's take note of this. So this is the process of extracting information from the raw data. Okay. And this is precisely known as what? Data analysis. So first, data science. Now you can say we have two definitions: data science and what? Data analysis. Data science is getting what? This guy told us yesterday that data science is a collection of techniques used to what? Extract values from data. So while data analysis is the process of extracting information from what? Data. Okay. So the purpose of data, or the purpose of data analysis is what? Is to extract information not only to make deductive reasonings, okay, but also to understand, to understood what lead to the process of carrying out this what mechanism, and also how they are being produced, and allowing us to what make possible forecast, which is prediction. This is very important. So the second objective of a data analysis or as a data scientist is to what? To be able to forecast possible responses in the future within a certain given period of time. That is the idea. So from what we discussed yesterday, we said it starts with what? A simple methodology. So there's a method that are involved, and at the end of the day, we have to develop what? We have to develop real methodology for generating models. So we cannot take the place of models out of what we are doing. So we must know what a model is. Yesterday we said a simple model is just what? Is just your equation of a straight line. Let me just use that as an instance. So your y equals what? mx plus c, your straight line. Meaning that if you graph this equation, all your data science, all your data values lies within all your data. Put them as x. Okay, let me take out that color. So all your data lies within what? Lies within the straight line. So most of your data are lying on the straight line. So this is so they intersect with the straight line. So that is what it's saying. So this is a good example of what? Of a model. So we must be able to create a model and be able to what? and be able to make somewhat prediction. So the predictive power of your model is very important. Okay. Gosh, my network has started again. That went off? Okay, meeting end in 15 minutes. So when it ends in 15 minutes, we join with the first one, okay? There, there is one of the link in the group. So we'll join with that one. So now, so we must know, so the two objective is to, one is you develop your model, two, your model should be able to what? Predict accurately. That is the idea. So now you can read that up later. So the domain knowledge of a data analyst. So for you to become a data analyst, because data science is just what you are using some techniques as a scientist. So, but for data analysts, what you are trying to do to make your data speak some information. What are those information you are expected from the data? One is this. You want to understand what the some of this. What are the possibility of carrying out these studies on the mechanisms of what of the system that you have that have produced them? So, how do we make focus? How do we make prediction? And what has evolved or what has changed in that period of time. So these are what you are looking at. So you are looking at the root cause of that problem, what is going on at the moment, and what will happen. So these are what you need to do as a data scientist, okay? Or as a data analyst. So you need some required knowledge to become a data scientist. This is what this guy is saying. So data analysis is basically a word in a disciplinary or a discipline suitable to the study of what problems that may occur in several fields of application. Moreover, the process of what of data analysis may involve so many tools and methodology that requires good knowledge of computing and mathematical and statistical concepts. Okay, so you've been given these are the three things you need. So whether you have a background in physics or computer or in biology or in so it doesn't really matter. You can develop these concepts. The beautiful part is that physics is more of mathematics and statistics has some relationship with what? With biology in any case. So you can, so with this, you are not missing anything. So computing, you're going to learn it in this course. So if you don't have it, so and one beautiful part is that um, statistical analysis, they are very easy, so we can also learn them. And the little math too, we can also learn them. So as long as you are committed to this, you will learn the required math and start building up on advanced math. So whether your background is mathematics, whether your background is non-mathematical or statistical, it doesn't matter. Okay, you can fit into it. So that's why it's highlighting here that mathematical concept and statistical concept are what you need to become a data analyst. So you can develop these skills. So many good analysts are able to move into different what disciplinary area. So you can read those ones up. And so as a computer data as a computer in computer science, the knowledge that's required in computer science is just what they are just simple things. You must have a basic knowledge of programming language, okay? So which is what we are doing, the Python language. So the C and the Java, they are a bit, they require a lot of time to study, but the Python is so simple. That's why I am recommending Python for this class. Again, as a data analyst, you must be able to understand data structure, okay, how data are being structured. All right. So if you have question, you can ask. So how data are being structured, so or how data is being stored. So this is also very important. So data is being stored in so many ways. In fact, in the modern way now, there are hundreds of ways of storing data. Okay. So now how data are being stored. One, data appear as XML. What is XML? Can you tell us? XML is just like Excel, your Excel. So in this course, we are also going to review how to use Excel, okay? I think you know Excel. So let me quickly show you a copy of Excel. MX Excel. Hmm, Office. Excel, yeah, this is Excel. So this is how Excel looks like. So Excel is this. So this is how Excel looks like. So let me say I want to save this page. So they don't so they usually call it okay, so they usually call, so this is Excel. So it's also a very powerful data analytics tools, okay, very powerful. This is the first the earliest data analytic tools that we have before we start developing your Python, your this, your that. So before we start developing them, so this is the earliest tool that we have. So we're going to practice how to use Excel too. Okay, you can create many pages as you want. So we're going to look into that as well, how to use Excel. So now this is the other data, the other file format that we have. We have JSON, the JSON file. So JSON file is more related to JavaScript, okay? But Python also have a way of defining a JSON file to recognize a JSON file. So this is what's it called? XLS is the same thing as CSV, okay? So XLS, sometimes known as CSV. CSV is a comma separated files. So means that the file is similar to Excel, okay? It's similar to Excel, but just that if you want to save your documents there, you're going to specify, okay, this one is Excel, this is not Excel. So that is just the difference. So you can also have that too in Google. So let me open the Google. So you can have this. Look at this. So this is sheets. You can see. Are we together? So go through Google, you see something like this. So if you don't have it in your computer, so you can just come to the, this is, let me go back again and show you. So you just come to your Google. So having, look at this page, Google, then you do what? You click on this button, Google app, and you have Google Sheets. So when you open Google Sheets, this is what? This is your Excel. You can see. So you create a new sheet. You can see. So this is not different from what I showed you earlier. So you can see this. So this is, so you can create your sheet. So you can use them for additions. So let me just quickly give us. So this is a column. Let me call it H, and let's go to the next column. Let's call it the age, and what do we call the next column? The maybe the height. And let's the next column is the weight. All right. So age is 20 years. Height is what's the height of the person in centimeter? Let's say 6. Let's say the person is 6 feet and the weight is maybe 50 kg. The other person is 30. Next, the height is maybe 5.5, is a female. The age is maybe 46 years old, 46 kg. Understand? So, are we together? Maybe the age is 39, the height is 5.3 or 5.8, and the weight is 80 kg. Understand? So, these are just three groups of data. Are we together? All right. So, then I can sum up their age together. So, this is sum. So, the sum of their age. Okay. So, let's find the sum of their age. So, this will be the sum of their age. You can see now. So, here's the sum of their age. 89. So, when you add up everything together, so we create a function using sum a2 to what? A4. We add 20 plus 30 plus 39, give us 89. So, what is the sum of their height? So, this is the sum of their height. And what is the sum of their weight? This is the sum of their weight. So you can see 2 is one of the earliest what's it called, tools for data analysis that we have. So we are just trying to what? To ask for more. That is why. So we can plot this. We can plot it and have a very beautiful plot from it. So let me look if I can get that so fast. So data, data. Okay. So all right. I'm trying to look for the what's it called? Insert into okay, draw function, check for. So I'm trying to check for a graph, but I can't find that at this moment. I want to plot it so quickly. So, but yeah, so this is one of the earliest this is one of the earliest data analytic tools that we have. Okay, so because we're asking for more, that is why we end up having Python, some advanced tools like that. So, all right. So now let's leave this. So go back to our text. Okay. So now we can. So we can also see CSV format. So CSV format is called comma separated format. So we're going to work with this file. So if I want a CSV format, so I'll just come here and save it. So save it as, where's my save? Okay. Okay, let me go back to this place. If I can have a CSV format here. Okay. I don't think Google provides us with one like that, but I think there's a way you achieve your CSV format here. So sheets, vids, slides. So CSV format always comes when you want to save it. So let me say I want to save this. Stop. Yeah. Okay, you can see now. So if I want to say, if I want to download it, yeah. If I want to download it, I download it as what? XFX. Is the meeting over? Yeah, welcome, Jennifer. Can you see my screen?
Yes, sir, I can.
All right. So we'll be using Zoom for now. Then later we'll change to Team. I think Team is one that works well here, but I will download the app maybe by tomorrow. So by next week we'll be joining with Team. Team is much more better. So Google Meet is just not supportive. Sorry for the inconvenience and everything. So let's continue. So Like Google provide us with what? With an Excel sheet. Okay. So this Excel sheet you can have. So when you want to export your file, so you can now say, okay, this is the format I want to export it with. So I want to export it as what? XLSX. So when we continue to do our Python, you will continue to see how to represent all these files in Python. Okay, as PDF, as HTML, as CSV, which is what comma separated values. Okay, and there's also called tab separated values. Okay, so when you download it as comma separated values, so let's see how it looks like in CSS format. So when you open it, you're going to see that, oh, let me open it with Notepad so you can see what I'm saying. So I'm opening it with a Notepad, and you can see this is height. It's being separated with what? With a comma. Can you see that? Yeah. This is weight. It's being separated with comma. Age. The values are being separated with what? With comma. That is why it's called a comma separated values. Is that clear? All right. So you continue to see more of these five formats. So let's go back to our page. So it said you can use it as what? So we can have a simple CSV file or what? XLX file or XML file or JSON file. So these are some common formats of what? Of representing your data. So most data are not also in what? They're not also, they don't come in files. So some are in the natural state. So I'm trying to get this data from natural state. So you use a method or a query method known as what? SQL. So SQL, SQL language. So SQL query language. So it's not a SQL query language, or you can just say SQL. So it means what? Um, Sequential queried what? Um, Language, SQL. So this is another topic entirely, which will lead you towards database. Okay, so you have knowledge of database. So as a scientist, you must also have what? Knowledge of what? Database. Okay, so and there are other methods, which you've seen earlier, HTML. HTML is what? Hypertext Markup what? Language. And we basically see this yesterday in our Python. So let me go back to our Python. Where is our Python script? I want to hide this. How do I hide it? It's disturbing me. So here is our Python. So all this we were typing yesterday. Look at this. This this is an example of what? Hypertext HTML, hypertext markup what? Language. So this is a markup what? Language. Okay. So when you type, so um Colab also provide us with opportunity to use what? HTML. So these are hypertext markup language. So you can see they have their own style of doing it. So you see when we make definitions yesterday, so we started, so you can see now we started with this. So with hash, with this on minus and things like that. So it forms, that is a hypertext what? Query language. So you continue to see more as we proceed. So when you use text in programming, so the hypertext query what? Language. All right. So now, so to get data from hypertext query language, you need a method called web scraping. Web scraping is also important. Okay. So we'll say all of this before we wrap up the course. So as we proceed. So another area you need to understand Your domain knowledge also lies in what? Mathematics and what? Statistics. So you must have good knowledge of mathematics and statistics. What we call the Bayesian method, which relies on probabilities, the regression method, which we've seen earlier, which is just your normal equation, which is what? Y is equals to what? Mx plus C. So your so this is cluster method, which relies on what? Mean. Your mean, median, mode, so your mean, so your cluster method, which you are trying to find distance between what? Distance between a point and its mean. So, so you have many of them. So this is your cluster method. So trying to find the distance between this. So some will use the norm of them. So all of this we're going to see them as we proceed. Okay. So for the meantime, don't be scared. So just get what? Just get understanding of all of it. So also you must have a good knowledge of machine learning and artificial intelligence, which we also discussed yesterday. Okay. So we said machine learning is just what? Is just a subset of data science. Okay. So also artificial intelligence. So in this field, professional field of application, you can read up this one yourself. So now we said there are different types of data when you are trying to work as a data scientist. So two of the most important categories are the categorical data and the what? Numerical data. So categorical data, they are just what? They are just data, categorical values data. So these are data or observations that can be divided into two common groups. So they said they are what? Nominal groups and what? Ordinal groups. So generally, numbers that are values or data that are not like numbers, they are called categorical data. Like for instance, when they ask a question, do you live in Nigeria? What will be your response?
Yes, I live in Nigeria.
Eh?
I said yes, I live in Nigeria, or should I say just yes?
Yes, yes, just yes. You can see it's not a number, right? Your response does not provide numbers. That is categorical data. They ask, uh, do you eat, uh, do you have a phone? You said yes. Is it raining in Nigeria currently? You said no. So when your questions are like yes and no, they are what? Categorical data. Or data that require you to provide, okay, some non-numerical data. They are called what? Categorical data. So, like for instance, they may ask if you fill some form, if you are filling some forms, they will ask male or female, right? So they will just put gender, right? They'll put gender in this column and they will say tick, is it male or female? You say male. These are also categorical data. They may ask a question, is it true that Bola Ahmed Tinubu is the president of Nigeria? You say true. If they ask, is it true that Nigeria has 38 states? You said false. So questions that takes true and false are also what? Categorical data. I hope this is clear.
Yes, sir, yes, sir.
Okay. So now How do we now differentiate between when it is normative and when it is nominal and ordinal? How do we say that? You know, we have them in we've defined categorical data in a broad sense now. So how do we say this is nominal and ordinal? Do you have an idea?
No, sir.
Oh, okay. So let me explain. Nominal and ordinal categorical data. So this this data, nominal data, they are just like how do we say them? How do we say them? Okay, let's say them in this way. Let's say them in this way. Nominal data, they are just like data that has no inherent order. We said a nominal variable has no in, intrinsic order to identify its category. Let me give you a good example. Color, colors. When you bring your data in form of colors, or when we use colors to identify data, maybe red, maybe blue, maybe green, we said they are what? Normative. And when there is an order of that data, how they are being predetermined, we say they are what? They are ordinal. For instance, education level. You have to be in SS1 before you be in SS2, right? Yeah. So there is an order you have to follow in those data. So they always say ladies first. Okay, so you give priority to what? Ladies in so many things. So maybe when you want to write those type of data, you say, oh, the female data first, So you are doing what? Order. You are giving order to female before male. You are giving order to a military man, or in Nigeria setting, you give order to the president, followed by the what? The Senate president, followed by the House of Rep leaders, and the Attorney General of the Federation, continue like that. So when you give orders as a rank to some certain type of data, you are doing what? Ordinal data. So maybe, for instance, you are looking at, maybe, let me give you a good instance. This will be so clear to you now. Don't worry. So this example now, you are looking at the height of what? Of 10 boys. Okay. You're looking at the height of 10 boys. So, okay, now let me use height. You are using a place. Let's say you are using, uh, okay, you are using a very cold, you are using a three region. You are using a three region Nigeria: Sokoto, Jos, and maybe Lagos. So we now ask, which of these states is hotter in terms of heat? Which is much hotter in this month? Sokoto is number one, right? So Sokoto has a high heat level. The heat in Sokoto is high. In Jos is what? Is low, right? In Lagos is what? Is medium. Is this one clear?
Yes, sir. It is.
So this is called ordinal data. Ordinal, ordinal variable data, so ordinal categorical data. So when there is an order, yes, high, medium, and low, you say they are what? ordinal. Maybe for instance, now you are categorizing the best bank in Nigeria in terms of time. Okay. Oh, you say, oh, on the average, Opay is the fastest bank in Nigeria. It's very high in terms of speed. In terms of speed, maybe which bank? Maybe let's say Kuda Bank. It's also is mediumly accepted, okay? And maybe all those GT Bank, they have their own problem. So the GT Bank is one of the low rated bank. Or so when you try to categorize your data in terms of which is better, so what you are doing is what? Ordinal data. Now that is clear. So let's look at it from this other perspective again. Let's look at it from the police. You started with what? The highest rank is what? The Inspector General of Police, the IG. So you always put him at number one. Number two, maybe you put the AIG, the Deputy Inspector General of Police, number two. Number three, you put the next guy, maybe the DIGs or something like that. I don't know much about the police anyway. So you continue to rank it in that order down. What you are doing is what? Ordinal data. So for nominal data, maybe when you use colors to make differences between your data, so without ranking them, so just like, oh, yes, so all red should be in this column. This is column for red. This is column for blue. So this is column for white. So all white values should go into this place. So when you are doing something like that, using color to differentiate between ordinal data, categorical data is their words normative. There is no order. So anyone can come first. You can say, oh, let all the reds come. Okay, you can even use names. You can say, okay, names. All names that are in that begins with letter A. We do that very frequently in the dictionary. So all names that begin with letter A should be in this, followed by letter B, followed by letter C. So when you are doing this type of ordering without any preference, so they are like what? Nominal data. All right. So the difference is clear, right? So from your
Yes, sir, it's very clear.
from your understanding, now, can you give me a similar example like that? A similar example.
Nice. So an example of nominal and ordinal
Categorical data.
categorical, that's categorical data. Okay.
Yeah.
So let's say we are looking for the coldest country in the world. So we now start with like in ordinal,
Ordinal.
that is based on order, that is the
Yes.
coldest.
Yes.
So that coldest is mean based on the highest, the coldest country. So it's like a priority.
Yes.
Yes,
Good.
that means the coldest. That's based on scale of preferences.
Yes.
So we have to go from the coldest to the least cold,
Yeah. Good.
like from Alaska to Basamagiba
I think one of the
to
coldest.
other country.
Yeah. You
Sir?
get it. I think you get it so correctly. Yeah.
Okay. And then when it comes to the other nominal, that is we don't do them based on any order. They are not based on any order, but we just like place them or arrange the datas either based on alphabetical order or
Or
uh,
order of magnitude. Which one is bigger?
uh yes, or sizes or
Yeah.
frequent or the latest ad or something like that.
Exactly. Yeah. You get it correctly now. So that is nominal and ordinal categorical data. Good. So the other type of data now, data that are what? Numerical. Okay. that are like numbers, like 1, 2, 1.5. You understand now? So numbers that are in form of number. For instance, I ask someone, how old are you? You say my age is what? 55 years. Good. It comes with a number. I ask, how many states are in Nigeria? Oh, you say it's 30 what? 37 states or 36 states. Okay. That's the Federal Capital Territory. All right. I ask, how many governors do we have in Nigeria? Oh, you say we have 36 governors in Nigeria with what? I asked, what's the size of Nigeria territory? How large is Nigeria? You told me that it's 9 point what? 9.2 kilometer millions kilometer what? Kilometer square. You said, oh, that's fine. I asked you, okay, what's the largest country? What's the size of the largest country in the world? Well, you say, oh, Russia is the what? Largest country in the world, and it has what? 17 million kilometer what? Kilometer square. The territory is like that. Okay, that's good. I can ask, okay, what is the date that that what's it called? That the Artemis 2 went into the moon or orbit around the moon. You say, oh, it's on the first of what? April 2026. You understand now? So these are ordinary numerical what? Numerical data. Okay. So, and some could be continuous, some could be what? Discrete. So when we say discrete, do you have any idea about that?
Sorry, sir, what do you say?
The difference between discrete data and continuous data.
Okay. Discrete and continuous. Sorry, I feel discrete is like a data that has an end, and then continuous data that there is still left an opening to be added. I don't know if
Okay.
something like that.
You correct. So we say discrete data are those data that we can count. Okay, that means there is an end to it. Okay, we can count them maybe from one to what? 1,000, 1,000,000, 1 billion. You can count them. So these are these are discrete data. So we can count them. Then continuous data, they cannot be counted. Okay, like what? But they can be measured, like your water. For instance, we can't count water because we can measure water in liters. Petrol, we cannot count petrol, we can measure petrol. Sand, we cannot count sand, but we can measure sand. Okay, so give me 2 pounds of sand, give me pounds of sand, give me 2 kg of sand, give me 1 bags of sand. You understand? So, like your water, give me 1 gallon of water, give me one, like your crude oil, give me 1 barrels of crude oil. So these are continuous what data. Like for instance, maybe time. This time is also what we can see it as discrete. We can also see it as continuous. Depends on, so maybe um okay, we can also look at maybe heat or temperature of a particular place. Oh, is 37 degrees Celsius. So that is just on a normative scale, but ordinarily we cannot say, oh, this is the amount of heat here presently until it is being measured with what? With your thermometers to see, okay, we have 30 degrees temperature here. So wind that blows, these are continuous data, okay? So they cannot be counted or they cannot be accumulated, but they can be measured with some wind vine to say, okay, this is the amount of wind that has blew within this world, this region. So these are continuous data. I hope this is clear. The difference
Yes, sir, it's
between
very clear.
categorical type of data that we have, categorical data and what? Numerical data. We have them to be what? Normative, non-normative. We have them to be discrete and what? Continuous. So Now we'll stop here before we'll just discuss this and go back to our coding. Let's see what we can code a little bit for the next 30 minutes and we'll call it a wrap. So, but let's just quickly look at data analysis process. So after this page, we can go back to our coding and code for like 10 minutes and we are done, okay? So yeah, data analysis process. Look at the process. A data analysis process can be described as what? Can be described as a process consisting of what? Several steps. It involves two things: transform data and process data. That is just the two things that is involved. So look, just turn your hand like this. You transform data. You just roll your hands. So just as if you are rolling your hands. So let me share my video so you see that. So that's what we see. Let me share my video in a minute. Can you see my video? So when you do like this is what we call you transform data. So that's the first thing. Transform data. Anytime you're given a data, you do what? You transform it, transform it, transform it, transform it. Then you do what? You process it. Transform, 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 and process. That is the idea. So when you have a data, data doesn't just come ordinarily. So you transform it and process it. So that is the idea. So you have this in your mind that anytime you have a data, don't just feel comfortable using that data, transform it first and process. Yeah. So after processing it, you can now produce them in what? In different formats. Maybe in visualization form, in predictive form, you can build a model, you can start doing so. These are the process of what? These are the stages involved in what? In in data analysis. First, define the problem. What is the problem? Then extract the data. I'll give you a clear illustration with this. What is the problem? Define, extract the data, clean the data, transform the data, explore the data, make prediction, make model, visualizing it, and deploy it. I showed a similar image yesterday for this in our in our previous class yesterday. So let me quickly, oh, yeah, let me quickly go to that yesterday. So I think this was it yesterday. Yeah, this was the image. I showed an image here yesterday. Yeah, this. Not this. Not this. Not this. Not this. Not this. Not this. Yeah, this is it. This was the image we showed yesterday. That understanding the business. That is like what is the problem? Understanding the data. That is what is creating your data, developing or extracting your data, preparing your data. That's like your transformation. Build a model, evaluate it, and what? Deploy it. You can see these steps here: 1, 2, 3, 4, 5, 6 steps that we have here. It's still the same thing as what we have here. Oh, meeting end in 10 minutes. Okay, so I will share on that link. Okay, I'll share on that link when it ends. But let me just quickly share that. So when it ends, you just create new
I'm
link.
sorry, sir. My phone is very low. I don't think
Okay,
it can stand another one, and we
okay,
don't
okay,
have lights.
okay. We'll end it up here after this. Then maybe next week we'll continue with the coding, or I can complete the coding and send you the videos. So, but let's just see, sure. So when I will send the video, I will add a little code into it. But let me just explain this part. So it's just like a patient who went to the hospital to tell the doctor that, oh, doctor, I am sick. Ordinarily, doctor doesn't know what is wrong with you. So the doctor asks you, how are you feeling? You said, oh, I'm feeling headache. That is the problem. Then doctor will ask you, since when? You're like, for 3 days. I think you've seen the data now. The data is just what, 3 days, right? Then later, doctor will not take that data and check, is this 3 days, is it correct? Can you have constant headache for 3 days? Yes. Then he transformed it and said, oh, your 3 days headache is not just as a result of body pains, as a result of some maybe malaria or typhoid or some other sicknesses. He has transformed it. Then he has explored it. Exploring it is like comparing it with what he has seen before. Okay, so then he do what? He make his model. Oh, this type of headache that has lasted for 48 hours is a critical state. Then it make a test. You get your blood sample, you get everything, you test it with what the model is saying. At the end of the day, you put them in the pictures and say, oh, this headache can be cured by what? By this type of drugs. Then he he used those drugs for what? For validation, and he's deploy them and give it to the patient. This example clear to you?
Yes, sir, very clear.
Yeah, so that is the process. So just have this, or you can think of other ones, other more example in your head. So these are the process of what? Of data analysis. So identify the problem. So when you are taken to an environment, a new environment, you are asked as a data analyst, study this environment and tell me the problem. So you just walk around, you can just see, oh, see some different type of buildings, see different type of road. You can easily say, oh, what these people are doing here, this is the business these people are doing here. Then you get your data and you analyze it. Maybe for instance, you is a malaria infected area and you just look at the whole area, you say, oh, because of the swamp in this area is the problem why people are sick of malaria. So then you check how many swamps are open, how many are closed, how many are stagnant, how many are flowing. You understand? So how many are covered? Is there any sewage around? Is there any? So you check all of those things. So you extract your data. Then you clean your data, make sure that they are valid. So we'll talk about all of this in our next class, one after the other. Okay, what does it mean? So this is all which made up of the system of what? Data analysis. So in our next class, we'll be talking about each of this process one after the other, which is what? Data extraction. We'll talk more about that, okay? So this is what we have done today. We'll be able to review that as a data analyst, these are the skills you need to become a good data analyst. First, you must be able to what? Have computing skills, mathematical skills, and what? Statistical skills. You must have that. And secondly, you must use to what? As a computer in the area of computing skills, you must understand how data are being stored in files, which are this type of softwares you can use to handle them. We said Python, we talk about Excel, we talk about CSV. So these are type of files that, and we also talk about the SQL, how your data can be what? How data can be gotten in its natural state, and how we can also use HTML to represent your data, and how you can get your data from different websites through a process known as what? Web scraping. Okay, and also we talked about your mathematical skills. You must understand the Bayesian models, which relies on probability. A intercepts B. So this is just your model. Then divided by what? The probability of what? The probability of B. So something like that. So of A. So this will give you probability of A union B. So that is your Bayesian model. Then your regression model is just something but your straight lines, and your cluster model talking about what? The norm distance between your a point in your data set and its mean. So this is just the idea of what we are talking about in your mathematical model. So this is what you build upon. And we talk about your machine learning, which we say is a subset of data science, which help us to build some models, help your machine or your computer to learn a pattern from existing pattern. That means there will be an output X, there will be an input X, there will be an output Y. Then your machine learn the patterns which it follows, okay, and to produce out what a result. So we've seen all of this. So as a professional, so we talk about types of data. You need to understand types of data we have: categorical data and what numerical data. And we say categorical data could be like normative and ordinal. And we also said that continuous data, numerical data could be like discrete or what continuous. And we lastly concluded by saying that data analysis process involve this what nine processes: one, two, three, four, five, six, seven, eight, nine. So involve these nine processes: problem definition, data extraction, data cleaning, data transformation, data exploration, model prediction, and model evaluation, visualization, interpretation of your results, and deployment of your solution. So these are what it involves. So next class will conclude everything and build more on our what on our skills of computing. Okay. So we can end of the class here and we'll continue next week Tuesday, like Monday or Tuesday.
All right. Thank you very, very much, sir. Thank you, sir.